Hi friends, welcome to OpenBook. Today we are gonna discuss about interval estimation. Okay, so in interval estimation, today in this episode, it is the first series of the interval estimation. So in this first episode of the interval estimation, a few things I'm gonna discuss. That is uh, maximum error, and second one is find out confident interval for population mean. So in this there is two conditions, that is where sigma square is sigma square is known, and second one is sigma square is unknown. Okay, so in this the first we should know the thing is x bar is the sample mean. Okay, and the sigma square is the variance of population. Okay, and S is the standard deviation of a sample. Okay, and their other term will be given in these problems, that is alpha is the level of significance, okay friends. Okay, so going to the problem, so I'm gonna first list out the formulas, okay, where sigma square is given, okay, and n is the its sample size. Okay, I forgot to write here, and n is the sample size. Okay, when sigma square is given means variance of population is given and n is greater than 30 or n is less than 30. Okay, so there is a formula, we should know this for the upcoming problems, that is x bar minus z alpha by 2 sigma by root n less than mu. Mu is the population mean, less than x bar plus z alpha by 2 sigma by root n. Okay, and another thing is when sigma square is not given. Okay, when sigma square is not given, he must give s standard deviation. Okay, standard deviation of sample, he give this in this problem. If it is sigma square is not given, so he must give the standard deviation of the sample. Okay, and thing is when the n is greater than 30, okay, that then this minor changes from this formula to the next formula. Now we are gonna write that is x bar minus z alpha by 2. So sigma is not given. Here the sigma is a standard deviation of the population, okay, and here the s means the standard deviation of the sample. So in the place of sigma we write here as s by root n mu and x bar less z alpha by 2 s by root n. And there is the other thing, okay, when sigma square is not given, and n is less than 30, then the formula will be it is a little bit it's little bit different than these two formulas we have written here, and that is x bar minus t alpha by 2 n minus 1 s by root n, okay, less than mu, and x bar less t alpha by 2 n minus 1 s by root n. So this formula, when I going to the problems, okay, I will discuss the very elaborately, deeply, okay. So let's do some problems, okay. Okay, some here the problem is given. The problem is given. It is a in this problem he not ask her. He just ask her here the maximum error. Okay. That is a team of, okay, this is a little bit large, but anyway it's very simple, you know. And a team of efficiency experts intends to use the mean of random sample of size n is equal to 150 to estimate the average mechanical aptitude. Okay, the problem is given. A team of efficiency experts intends to use the mean of the random sample of size n is equal to 150 to the estimator, and it is a waste of this time, you know. We are going to the directly go to the problem. We just find out the terms. Here the given is sigma, and it is 1 minus alpha, means confidence interval, right? And another term n is 150. Okay, just rewrite these terms as it is the given here, and just writing these things. And n is the 150. N is 150. Sigma is 6.2, and this is the 99% simply, okay, confidence interval. So here he is given, he asked us the maximum error, okay, maximum error of their estimate, okay. So maximum error of the estimate is the nothing, we already written the formula, that is x bar minus z alpha by 2 sigma by root n. Here the z alpha by 2 sigma by root n, this is, then this is the maximum error, okay. Okay, so here the problem is given. here the n is greater than 30. Okay, and here sigma is given, so that's why we are taking from these things. Sigma square is given, that's greater than 30. Okay. So I'm writing here, I'm finding out this problem. So maximum error, we should write a maximum error is equal to z alpha by 2 sigma by root n. Okay, that is, here the each one is the, if it is given in the percentage, we can write it as in the form of 0.9n decimal form, or it is, if it is given in the decimal form, we just think here it is 1 minus this is, here it is given is 1 minus alpha, so that is 0.9. So we have to find it alpha by 2, so alpha is a 0.01 and alpha by 2 is the 0.01 by 2 is a 0.00 much 5. Okay. Okay, so and the formula we already has written, so we just do this z alpha by 2, we have to substitute this form 0.05 and the sigma is given 6.2 and the root n is given 150. So where, see, there is a 4 values, the important values you should remember, that is for the confidence interval for the z table is given 90%, 95%, for 98% and 99%. So here you should remember these values, because of every time you can't see the table for every simple value. So mostly every question asks the 90%, if maybe he asked the 99% or 98% or 95% or 90%. So in this problem he has asked, he has given that it's 99%. So the 99% for the confidence interval, the value is the 2.58. so the value is simply, you can write as a 2.58. Okay, 6.2 by root 2 by 150. So the final answer is the 1.30. Okay, and so I'm already told the things I wanna. First we did the maximum error, it's completed, and now we are gonna discuss about the confidence interval of the population mean mu. So the population mu, okay, so let's go to the problem. See, here is given sigma square n is the next 20 and sigma square is the 225 and x bar is the 64.3, and here is given 95% confidence interval. And I already told you that if n is greater than 30 or less than 30, we don't need to think about it. We just think, first we have to think if sigma square is given as not given. Okay, here the sigma square is given. Okay, we simply go to the going to the problem, that is we have the, already we know the formula, x bar minus z alpha by 2 and sigma by root n less than mu, and x bar plus z alpha by 2 sigma by root n. Okay, here the sigma is given 64.3, okay, and z alpha by 2 for the 95% confidence interval. Okay, I have already told you we should remember these values, and 1.96 for the 9.56 for the 95% it is 1.96. so here it is 1.96, and sigma has given already, it is a sigma square, we convert into the sigma square Okay, the sigma is simply 15. So okay, the sigma is 15 and the root under root or 20, and we simply the same terms as given, just the plus, sorry, 64.3 plus same thing as it is. Okay. 15 by root 20. Okay, we go to this go through this all these things. We get answer 57.7. Is there mu? Is there that is 70.9. Okay, it is over. So what we did is here, when sigma square is given, and we don't need to think about if sigma square is given, we must think if sigma square is given, we don't need to think about if it is less than 30 or greater than 30, because of any here I'm already told you this thing, that is already told you that thing is when sigma square is given, we no need to think about if it less than or greater than 30. So we need to think about when the sigma square is the not given. Okay, so I'm gonna do this on the problems when sigma square is not given. I'm also to the thing is, when sigma square is not given, he must give the s, means the standard deviation of the mean. Okay, so the second problem I'm gonna do, that is when s is given, n is the 40 and x bar is the 64.3 and 99% the confidence. Okay, so that is s is given how much, 8.4. Okay, and n is the 40 and x bar is 64.3 and 99% is confidence interval. Okay, so okay friends, I told you the formula, that is when sigma square is not given, here we go. Okay. And sigma square is not given and n is greater than 30. Okay, so here also n is the greater than 30, 40 means greater than 30. Okay, so here we have to use this formula. It is very simple. When the in the place of sigma we use s. It's very simple. It's no need thing. Okay, I'm gonna just substitute the formulas. Okay, substitute the values here. Now x bar minus, okay, first I'm writing the formula s by root n, then x bar plus z alpha by 2 is the s by root n. So simply substituting the values in 64.3 minus z alpha by 2 for the 99% confidence interval. That is the value is for 99% confident, it is the 2.58. So 2.58 and it is 8.4 by for n value is the 40 and 8.4, that is the same as it has given here. Okay, that is 40. Okay, here simply we calculate and we get some values and something. Okay, so that this part is the most important. Okay, when it is the most important, you should know this is a little bit tricky also. So the thing is, when sigma square is not given, okay, and n is the less than 30. Okay, so I'm gonna take one formula here. One formula, that is take some sum. Okay, that is when x bar is equal to 66.3 and s is equal to 8.4 and n is equal to 12 and 95% is confident interval. Okay, that is when x bar, no, I told you first we just rewrite the formula has given, we already written here. That is the x bar minus t alpha by 2 n minus 1, that is x by s by root n. Here friends, the thing is n is 12. Okay, so we have to find a degree of freedom, that is the n minus 1, that is 12 minus 1, that is 1. So that's why this is the 11, sorry, 12 minus 1, sorry. And that thing is that we know that that is a 95% confidence interval. So the 95% confidence, we know that the 1 minus alpha is a 0.95. When the higher value is given, like 90%, 99%, 98%, that is the 1 minus alpha. Okay, so 1 minus alpha is equal to 0.95. We change to this, and 1 minus 0.05 alpha become, and alpha by 2 is the 0.0 much 25 s. Okay, so that is okay. I'm gonna make a diagram, make a graph like this. It's very easy, you know. Here this is the full is the area of 1. Okay, so remember there is a full is 1, this full is 1, and this is the 1 minus alpha. Okay, this is the alpha by 2, and this is the alpha by 2. So if you add that, we get the alpha by 2 plus 1 minus alpha plus alpha by 2, then we get the 1. So okay, so that is this full area is the 1. Okay, here this value is okay, and here this shaded. Okay, this shaded is the 0 point, like here that is a 0 point, sorry, this is the value of 0.025, and here that is 0.025. Okay, and this is the remaining that one, that is the 0.95. Okay, so here I'm here the t is no sorry sir, is t of 0. That value is here friends. This is the okay, this is the t table. Okay, here the t table, we want 0.025, that is the 1 from the 1 till it is 0.025. okay, and already in 0.025, and for the degrees of freedom is 11, so that is 11. We go like this, we see exact the values is 2.201. okay, from the table we already seen that thing is from the t of 0.025, and the degrees of freedom is 11, so that value is the 2.201. so you simply substitute in this formula, in the above this formula. Okay, so this formula we substitute the x bar is 66.3, and then in the place of the t of t 0.025 and degrees of freedom 11, the value is the 2.201, and s value has there is given that the 8.4, and n is the 12. so we finally get this answer 61.0, and the mu less than mu, and this is the population confidence interval of for the 95% confidence interval population mean. Okay, so thank you friends, thank you for watching this video. Please like this video, share, subscribe. Thank you.